Welcome to the next episode of Endoscopy Essentials. It's again a very special episode because with our main partner, Olympus, who is one of our main sponsors, and we are very grateful for this, we go into details of the new endoscope generation, the EVIS X1. And I think it doesn't harm if we understand what we are doing. We understand it ought to be a better endoscope, but we want to understand the features. And for this reason, I heartily welcome Mr. Ingolf Mesecke-von Rheinbaben from Olympus Europe. He's in the digital health team, but he's also an engineer. So who could better explain the features, hopefully in a simple way, than you? Welcome.
Thank you very much for having me.
So the expression is EDOF, extended depth of field. That means a better image, close up, which sometimes in the older generations were a little bit blurry, but also in the distance where it became dark. Is this now solved?
Yes, you can say that. I think we pretty much solved this. So let me briefly explain what the extended depth of field function is all about. You already explained the idea is to have a continuously sharp image. And in order to understand the technical principle a little bit, we need to go back to our physics class and remind ourselves, how an optical system works.
Not my favorite topic, but yeah.
Okay, we make it short. So you always have an object here, like on the left side, an optical system and then a sensor. And as long as this object is in this range of what is called depth of field, then the projection of this object will always be exactly on the sensor. And that means we have a sharp image. If the object moves away, or everything that is outside the depth of field, that will also be projected through the lens, but the focus point, the sharp image, will either be slightly before or behind the sensor. So we get, at the sensor side, we get a blurry image because it's not in focus. So how do you typically resolve this? You can either move the object, or you have to move the sensor or the lens system, which always requires somebody to do something, press a button. Now, coming to EDOF, you all know that the image sensor technology has advanced quite a bit. So higher resolutions have been available now. And the question for endoscopy was, shall we do in this new technology actually a higher resolution image, means even higher than high definition? And the decision here for EDOF was, no, we utilize this technology, the higher resolution of the image sensor, for the extended depth of field. And this is how it works. You see on the left side there is the typical optical system. And then the image, which is coming in, is splitted into two. So we get two identical images, but they're not exactly identical because there is a difference in distance between the mirror 1 and the object and mirror 2 of the object. So we get actually two images which show the same, but one is sharp in the near field and the other one is sharp in the far field. From that moment onwards, we can use normal computer technology, identify in which image which parts are sharp. And once that is done, we only need to merge the sharp elements together into one. So you get one continuously sharp image and you don't have to do anything. It's always available on the video stream. You don't need to press a button. Very easy to use.
So it seems that two focus points are enough, so you don't need 10 or so, because you can't look so far anyway. Is that correct?
That's correct, because the biggest problem for things getting unsharp is actually the part which is in the near field. The focal or the depth of field actually in the far field is easier, is already there. It's only this portion between 1 and 3, 4, 5 millimeters where it's really difficult.
So it's like a non-magnified magnification view plus the rest of it.
Exactly, yeah, you can describe it like that.
Okay, good. So this was a beautiful explanation, but there's one more feature I think which is often mentioned, which has to be explained. BAI-MAC.
Right, very strange name. So BAI-MAC stands for brightness adjustment imaging with maintenance of contrast. I know it's a little bit artificial, but it's important because the brightness of an endoscopic image is not necessarily evenly. Everybody knows that from using endoscopes. So this is what this technology tries to solve. And how does it work? You see on the left side there is an image which is nicely illuminated in the front part and quite dark in the back, which is very typical. Now if you would simply increase the brightness of the light source, which is possible, then yes, you have a better illumination of the back part, but you have a white out in front, and then you don't have good visibility in the front. So the BAI-MAC function here, technologically, it splits the image into a texture part and the brightness part. And then you can adjust the brightness separately from the texture. This is important because if you do it on the white light image as it is, then any change in brightness or texture would influence the other. That's why this is being done. And then the nice thing is that when you adjust the brightness, you can not only do it on the full image, you can do it selectively of the different parts of the image. So for the back part, which is dark, we can increase the brightness, and we can keep the brightness of the front part as it is. So again, you get a very homogeneous image. Besides EDOF having everything sharp, you now have also a very constant and even brightness across the whole image.
Okay, thank you. So a lot of work in the background to make something look beautiful. It's like in a movie. But now we want to have the movie. We want to see what do we do with this technology. And for that purpose, we go to Stefan Seewald. Professor Stefan Seewald is working in Zurich, and he's an ingenious image and movie maker and filmmaker of endoscopic pictures. So Stefan, what's EDOF? Explain it with videos and images.
Okay, so I have prepared 2 videos for you to demonstrate you EDOF and BAI-MAC, and this is the first video is from the colon, and here you see the comparison of the previous generation of H190 colonoscopes and the new feature of 1500 X1 colonoscope, and I think this is the same patient, same position, and here you see the illumination of the cecum. So what you can nicely appreciate here that we have a fantastic illumination in the near and in the far field at the same time. And when we look to the older processor, to the old scopes, you will notice that if we want to have the light brighter here in the area of the cecum, you will get an overexposure of light in the near field, and this will disturb the visualizations. So here you can nicely appreciate this is an harmonic illumination of the whole space. This is BAI-MAC, and what you can also notice here very nicely on the right side, that you have a sharp image in the near and in the far field at the same time. And when you watch here, the image is here sharp, but in the near field it's not that sharp. So this is the new feature of EDOF, and I think this is very impressive, especially when you perform colonoscopy.
So I think it's not difficult to judge what's old, what's new from this example. Not knowing what the features are, but you appreciate the differences.
Yes, I think what is impressive with this new technology is the sharpness of the image, and there are several points. For sure it's the light, it's the illumination, but also this feature of EDOF makes a very sharp image of the whole picture, near and far field.
Stefan, that's the colon. Do you have some other organ as well?
Yeah, for sure. I have a nice example from the esophagus. Also a comparison video. Left side old processor, right side new processor. And this is also same patient, same position. And when you focus here now on the right side, you also may appreciate that you have a sharp image in the near field and in the far field at the same time. Compared to this image, this is a little bit blurry compared to the 1500. And you may also appreciate that also the illumination of the esophagus is very harmonic compared to the left side.
Yeah, here you have the same distance, right? And
Yes.
you see more details on the right side.
For sure, this is now also NBI. I used here NBI, and especially here in the squamous cell early cancer, you may notice that the NBI image is brighter and for sure also sharper, not only because of the NBI filter, but also due to EDOF and BAI-MAC.
Oh, I see. And on the left side, the distal part is not well seen. It's too dark. That has been one of the slight disadvantages of NBI all the time. So this is obviously now solved.
Yes, but you know, when we used NBI, we always had the problem that it was somehow too dark. And also this is especially in the stomach as well. NBI is too dark, but with the new technology, I think this is a breakthrough that we have a bright NBI.
Also in the colon, for doing a routine withdrawal with NBI, I think we tried initially, but...
Yeah, it's always the discussion if we should perform a primary NBI colonoscopy, but with the old processor that was too dark. But maybe this is a new chapter now with a new technology.